Hello, everybody. This is Sairam Gitanath, and I'm excited to challenge all of you to build an accessible stroke MR for India. This is briefly what I'm going to be talking about. I'm going to be telling you a little bit of stroke numbers in India and the need for accessible MRI for stroke imaging. Um, Go on to list a set of desired features of such a scanner, and then get into defining the challenge itself. I'll follow then with defining the sub-aims and potential outcomes of how these sub-aims would result in. I'll also point you to some open source tools that you can actually use to accomplish this. So let's get started. Um, Stroke is the fourth major cause of deaths in India, and it has high prevalence per 100,000 people. On the right hand side, you might see some of the statistics over the years from different groups that have actually looked at stroke. And the prevalence is typically between 105 to 150 persons for every 100,000 people. American Society of Neuroradiology recommends MRI for stroke imaging compared to CT. This is specifically because of the ischemic stroke subtype rather than the microbleeds and the hemorrhagic stroke, and the role of diffusion that enables this classification better compared to CT. Globally, there are 5.3 MRI scanners per million people. In the US, it's about 36.72, but India is a mere less than one. Couple this to India's population of 1.32 billion people, this then becomes challenging to accomplish WHO's definition of accessible MRI devices, which is to improve equitable access to safe, high quality, reliable, and adequate technologies and clinical services. So, one might feel that India would actually need accessible MRI for stroke imaging. To further define what accessible means, we consider five dimensions, mostly being geographical, which is to be able to access MR scanners in remote locations and enable time sensitive imaging, specifically as required in stroke. Uh, Temporal access that provides for time opportunity cost, either through accelerated exams or MR value driven protocols to provide for a focused stroke exam. In India, it has to be an affordable MR exam. Uh, it also has to be tailored to the Indian demographic to enable precision medicine, and that's the cultural component of access. Um, Such a scanner, if it's deployed in challenging environments, has to be self-supporting and intelligent, capable of autonomous operation to ensure that local expertise is not required, as well as to enable a careful watch of self-degradation of the scanner. One example that comes to mind is the study published in Lancet, which talks about um, the number of stroke deaths in Northeast India being one third of the total deaths in India, and this is a population of approximately 78 million people. So on the right hand side, you can actually see across two time points as to how the northeast part of India, which is hilly and has geographical access challenges, is also the hotspot for stroke incidence and mortality. Well, then, what we need is, in our opinion, a helmet like scanner, which can produce images that you see on the right hand top corner, which has a clean labeled core, penumbra, and probably normal tissue that you can look at with flare and diffusion images. So then, what are the features of such a scanner? You would need this to be a point of care device rather than a multi-million dollar scanner that sits in a huge facility. You want this to be light, portable, sturdy, low power, and low cost. Like we did mention in the previous slide, it has to be self-supporting and independent of local expertise. However, it should produce clinically acceptable image quality and a first read report that has a labeled core, penumbra, and normal tissue. The scanner should also provide for continuous protocol evolution based on reflection of previously acquired data. The challenge then is to develop or design this accessible MRI stroke for India with three specific aims. One is to develop this scanner tailored to geographical and temporal axis dimensions. This could be done at very low field between 10 to 100 millitesla or any other choice um, that people would want to take a stab at. The second one is to demonstrate feasibility of diffusion weighted imaging at these fields for stroke diagnosis. The third aim then is to generate a first aid report that labels the three components that we were talking about. The solution could also include a roadmap to market, which revolves around the strategy for hardware assembly and/or development, a strategy for beta testing, and a tentative business plan. So, if you put all this down in time, you would derive milestones 1 to 5 based on the blocks that you see at the bottom. The expected outcomes of the first aim would be the technical specifications of such a magnet in comparison with some of the other magnets in a rather other scanners shown in this table. The table by no means is conclusive or comprehensive in either the rows or the columns, but these are the numbers that need to be derived through simulator M1 and M2. The outcome of the second sub aim would be to optimize parameters for diffusion acquisition, such as the kind of readout trajectory and the duration, the trade off between echo time and the contrast, the acquisition bandwidth, the maximum gradient amplitude, the different diffusion acquisition parameters, and um, incorporation of either motion detection, correction, or mitigation. On the right hand side, you see some of the preliminary data that have been looked at in the current year ISMRM, trying to understand uh, the role, the contrast that can be generated using diffusion with the kind of B values and the deltas that you can actually use at about 10 millitesla. Um, the outcome of sub aim 3, like you would have guessed, is the classification in the first rate report. To this end, it could leverage the IELTS dataset, IELTS database that's public and also shown in one of the references here, which has 28 training and 36 testing, with the ground truth also available to you. One of the desirable requirements is desirable characteristics could also be the combination of electronic health records to arrive better at classification of both the tissue and stroke. Here are some tools that might help in accomplishing this challenge, which are all open source and available on opensourceimaging.org. Um, Pulsic GPI is capable of um, deploying pulse sequence pulse sequences, image reconstruction, and image analysis methods. The minimum field simulator would help you determine what's the minimum field to accomplish a certain contrast. Um, Okra is um, an open source console that you can use to plug in as part of some of the hardware that you might need for the scanner. Um, Diffusion imaging in Python gives you a way to explore the inclusion of diffusion, and of course some work in trying to tailor that to the field strength that might be useful. And like we mentioned in the last slide, the IELTS database and the challenge. Here is a template of a tentative business plan. Uh, the font in purple are the ones that need attention and filling out, which is predominantly focused on who the targeted customer would be at each stage of development, and how many units would one want to make to ensure that there is a sustenance of such a scanner. Um, Importantly, all of these prices um, needs to be in the Indian rupee. Finally, I'd like to thank Lucas for this opportunity under the Junior Fellows. I'd like to thank ISMRM for such a fantastic program and bringing out such needs. The Indo-Portuguese Joint Research Program that we funded off, which allows to take a stab at some of these things, and the team members of that project. I'd also like to draw your attention to a workshop that we have in New Delhi in India between 29th and 31st of March, focusing on accessible MRI for the world. Um, the abstract deadline is on 23rd of January, and we would love to see all of you in India. With that, I'd like to thank all of you for your attention. Um, Apologies for my absence, and if there are any questions, please do feel free to either contact me via my email or Lucas for any quick exchanges on these questions. Again, many thanks for your attention.